So part D, kind of the same idea, right? E, okay, what's E? E is that number 2.718, blah, 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 blah. If you want to solve this, you got to get the exponent to fall down. So you could convert to, I suppose, logarithmic form, right? And that would work. But I want to try the more general method of taking a log of both sides. Now, your calculator has two main logarithms, log, which is log base 10, and ln, which is log base e. Which one makes sense to use here? Yeah, so I'm going to rewrite it. And instead of taking, I mean, it would work to take log of both sides, log base 10, but let's try ln, because I want to show you how this simplifies. So we're really inserting both sides into the natural logarithmic function. That's what ln stands for, the natural logarithm. Now, I'm going to put in an extra step here, because the first time you see ln, it's hard to rectify it in your mind with the notation, the other notation for log. So what ln really means is log base e, log base e, log base e. So what we're really doing is we're taking log base e of e to the 3x and log base e of 10. That's what that ln notation really means. So don't let it scare you. It's just another logarithm with base e instead of base 10 or whatever. So why did we take log base e of both sides? Well, okay, remember that property? Log base a of a to the x is just equal to x. It's like the exponent just falls down. We can use that property on this side. What's log base e of e to the 3x? It's just the exponent, 3x rather. Another way to look at that is your composing inverse functions, remember? The natural exponential function is your input. Well, e to the 3x, it's not quite the natural exponential function. E to the 3x is your input, and ln is your output. Those are inverse functions, so they undo each other. So just that guy is going to fall out when that guy's acting like what we normally think of as x is going to fall out when you compose those two inverse functions. And then on the right side, we'll just leave it as ln of 10. And then, there's only one additional step here. You have 3x instead of x, so what do? 3 times x, so just divide both sides by 3, and you have your answer. So you have x is equal to ln of 10 divided by 3. There's your exact answer. On the calculator, you can locate the ln button. It's just one below the log button. So ln 10 divided by 3, get about 0.77 if you round. Approximately equal to 0.77. So realize this is an approximation. It's an estimate. This is exact. And know the difference, right? If I tell you to get the exact answer, don't give me an estimate. Here are the steps, by the way, for solving what I would call routine exponential equations. That's what we just did. There's other kinds of exponential equations that aren't so routine, that take creativity. We're not going to worry about those in this class. You can do that in your next life, right? Your next math life, which is college algebra, perhaps. So if you look, you may or may not have to apply all of these steps. Number one, isolate the exponential function if necessary. So that was like part B. If you look at part B, we had to divide both. It was 2 times 3 to the x equals 8. We had to divide both sides by 2 to isolate the 3 to the x. So, I mean, that's not always necessary. It wasn't necessary in part D, right? But if you do, if it's not already isolated, you need to isolate the exponential function. That's number one. Number two, if possible, write both sides of the equation with the same base, set exponents equal, and solve. That was part A, right? And then part B and D, we did step 3. If step 2 doesn't apply, then take the log or ln, really doesn't matter actually which one you do, of both sides, apply the power rule, and solve. Those are the steps.